Okay, I so today our topic is AIOps. So what is AIOps? AIOps stands for artificial intelligence for IT operations. So today we will discuss what is AIOps. Then we will discuss we'll give a motivation example in order to know uh, so how AIOps works. Okay, and then we will discuss some sub areas of AIOps research, and then we will discuss some common techniques used in AIOps, and finally there will be a hands-on tutorial. Okay, and so we will use uh, a we will use a tutorial, and we'll use the existing code to run a small experiment to understand the workflow of an AIOps solution. Okay, so first, so what is AIOps? Okay, then before we want to discuss what is AIOps, let's first discuss what is ops. Okay, ops, what is IT operations? So ops is so when you are using, for example, when you are using a web service, right? When using Facebook, and there are some people and there are some techniques, some infrastructure behind the Facebook UI, right? So actually, there are some people, some techniques, and some resources to manage how Facebook works. They operate Facebook. Okay. And so what is ops or IT operations? It is the people and the management processes associated with IT service management to deliver the right set of services at the right quality and at competitive cost for customers. Okay. So this is a definition of ops. So how ops works? Okay. So initially, so there were some manual operations. This is the traditional system administration. For example, in a university, the IT administration personnel, they may manage the services delivered to the staff, to the students manually. Okay, they will deploy the systems, they will operate the systems, and they will fix issues of the systems manually. Okay, so then it comes automated operations, because manual efforts are very expensive. So people started to use automated operations. So how it works actually, so people would automate the sequences in the manual operations. For example, traditionally people may just install some software and fix some issues step by step using a manual. But later on, they may code these steps into some scripts, so they can just run the scripts and do this operation automatically. Okay, so started to have reusable scripts. This is automated operations. So then comes DevOps. So DevOps combines software development and operations to shorten the delivery cycle. Okay, so let's have a detailed look at what is DevOps. Okay, so we know traditionally software development and operations teams are isolated from each other. So there's a development team, there's an operations team, right? So the people who develop Facebook is different from the people who operate Facebook, right? So these two teams have different goals and use different sets of tools, right? And so developers, their main goal is to release the product. So the operators, their main goal is to ensure the quality of the delivered services and try to fix issues during operations of the services. Okay, and they use different tools. Developers, they use software development tools such as IDEs, such as continuous integration, and such as debugging tools, right? But operators, they use another set of tools. Okay, So DevOps is a culture that aims to break the development operations barrier. So within a DevOps culture, the development and operations teams, so they are merged into a single DevOps team. So in this DevOps team, the engineers work together across the entire software lifecycle, from development and testing to deployment and operations. Right? There are many benefits of DevOps, including the improved collaborations between different roles, such as developers and operators. Also, it improve the speed of delivery, and also get faster feedback from customers because you are delivering the services to customers frequently, right? Okay, so within this DevOps cycle, there's an important component. This is a monitor or software monitoring. So it is an important component of the DevOps lifecycle. So during the DevOps lifecycle, so engineers monitor the software systems. They monitor systems to understand the state of the systems, understand the runtime behavior of the systems. So they use techniques such as logging, as we discussed last lecture. Okay. So during the software operations, the monitoring will produce large volumes of data, monitoring data, so including logs, right? Metrics. Metrics are about performance counters like CPU usage, memory usage, network usage, and throughput. Those things are about metrics. Traces are like more detailed recording of the runtime behaviors. So normally traces are not used in a production environment. Okay. So by capturing and analyzing the monitoring data, so engineers understand so what happens in a production environment. So they understand what's the impact of their changes to their product. They understand the root causes of runtime problems, so they can find evidence of unexpected runtime behaviors. Okay, so this is data generated during software operations. We call it monitoring data. Okay. So software monitoring becomes even more important. So nowadays, so when people started to adopt the idea of testing in production, so traditional people would conduct comprehensive testing before the software is released, before the service is released. But nowadays, software products are released very frequently. Like they are released like every day or like every few hours. Like Facebook is released every few hours. So under a short release cycle, software systems cannot be comprehensive tested before release, right? So people need to rely on testing in a production environment. Actually, when you are using Facebook, so the engineers of Facebook may be testing Facebook at the same time using your usage data. Okay. So they are monitoring your behavior and they're monitoring how the system responds to your behavior. So in this way, they can verify whether the behavior meets their expectation. Okay. So under testing or in production, so software monitoring is even more important. Okay. So we talk about the importance of software monitoring, but so when you're monitoring something or when you observe something, you're actually changing it. So there's a observer effect in physics, so which is about the fact that so when you're measuring a physical system, so you are changing the physical system. For example, so when you are measuring the tire pressure of the tires of a vehicle, you let out some of the air. Okay, that is observer effect. So observer effect applies to monitoring of software systems. So for example, so when you are monitor the software system, when you put logging statements in the software system, so the execution of the logging statements would require additional computing resources, such as additional CPU memory, additional I/O. They need to write the logs onto the disks, right? That is additional computing resources. Okay, so this is a challenge of software monitoring. Another challenge is the increasing volume and the complexity of monitoring data. So nowadays, a large-scale software system that produce a very large amount of monitoring data. Typically, a large-scale software system can produce billions of logs, metrics, and alerts every day. In comparison, our human brain currently has a short-term memory of 7 to 9 items. So our human brains are comfortable with handling hundreds to thousands of events. So we've now reached a point, so we cannot rely on our human brain to cope with the volume of the events in the environment. So we need AI. So we need artificial intelligence. Okay, so this is another challenge in facing software monitoring. So what is AI, right? So AI, artificial intelligence, is a simulation of a human intelligence processed by machines. Sorry, it's a simulation of a human intelligence processes by machines, right? Especially by computer systems. Okay, so the processes include learning, reasoning, and self-correction. So typically 2 types of artificial intelligence. The first one is knowledge-based approach. What is knowledge-based approach? Is we have the knowledge of how it works, and we have the rules of how it works. So we convert the knowledge or the rules into automated program. For example, for an autopilot system, so people use autopilot system to navigate the airplane, right? So the rules, how the airplane would travel, it depends on the rules. These rules are written into the program of the airplane. Okay, so this is a knowledge-based one, right? We already know the rules before we write it. We write the program. Okay, another one is a machine learning-based approach. We don't know the rules. We learn the rules. That's machine learning-based approach. So this approach automatically learn the rules from data, such as AlphaGo, right? So we don't set rules about how AlphaGo would do each steps, would operate each steps in a chess game, right? Instead, we need AlphaGo to learn the rules from lots of chess games. Then, so whenever AlphaGo is playing a real chess game, the robot would actually apply the rules it learned from the past. Okay, there's a rule-based approach, 2 approaches to AI, knowledge-based and machine learning-based. Nowadays, a machine learning-based is usually more popular, right? Because it's very hard to understand the rules manually and write it to a program. Okay. So what is AIOps? As we mentioned, so AIOps is artificial intelligence for IT operations. According to Gartner, so AIOps enhances IT operations through greater insights by combining big data, machine learning, and visualization. If you look at this figure, right, the input on the left is the input to AIOps. In the middle is the components of AIOps. On the right are output of AIOps. We see for input of AIOps, we see monitoring data, including logs, metrics, right? and wire data. So wire data is the the data that travels on the network, like how many HTTP requests from this machine to another machine, right? That's the wire data, document text. So this data are input to AIOps. What are the outputs? Outputs actually are the activities or tasks during IT operations, right? So these tasks include historical analysis. So we want to understand what happens in the operations. We want to understand the user usage patterns, how users use this web service, right? And anomaly detection. So we want to understand whether there's a problem. Performance analysis, understand the performance of the system, and also correlation and contextualization. So this is about how to associate different data together, right? At the central of AIOps is techniques, including machine learning, big data, also include visualization. Okay. Um, so in one sentence, so AIOps leverages artificial intelligence techniques to analyze the monitoring data and the operational data to give suggestions for IT operations, to provide automations for IT operations. Okay, that is AIOps. According to Microsoft, so AIOps addresses DevOps challenges with AI. So these are two different definitions of AIOps, but they are very similar. Okay. Okay, so we talk about what is AIOps. Then I want to give a motivating example to see a concrete AIOps solution. Okay. As we know, a software system usually would process a workload, right? So like still the example of Facebook. Facebook would process millions to billions of users using the web service every day, right? So the number of users can be considered as a workload. Okay. So under a certain workload, the software system would expect a performance. Performance can be CPU, memory usage, can be throughput, can be response time, right? Uh, so when the workload changes, sometimes the performance may become unsatisfiable. For example, response time becomes too slow because there are too many users at this time. So we need to do some configurations to the system. We want to change some configurations. For example, we want to change the queue length, how many users in the queue, right? If the queue is too long, then the response time might be too slow, right? So for large scale software system, there are usually many configuration items. Okay. So the workloads are constantly evolving. So we require constant human intervention to ensure optimal performance of the system. As we know, so human interventions, human efforts are very expensive. Okay, so can we reduce the human efforts? Can we use the AIOps solution to automatically tune the system configurations and achieve the optimal performance? Right. So that is the goal of this solution. So how it works is have a simple idea of how it works. Given the original software system, it produces monitoring data, including logs and metrics, right? So our first part is to analyze the monitoring data. We call this part as the first part is to connect and analyze the monitoring data. We call this part as a self-monitoring. So using the connection and analysis of the monitoring data, we know what is the performance of the system at each time, right? So this is self-monitoring. So after we understand the performance of the system, based on the performance of the system, so we can optimize the configurations. We can search for the optimal configurations that can achieve better performance, right? So we call this part as self-optimization. Then after we find the optimal configurations, we need to set the configuration values to the original system. We call this part as a self-configuration, self-configuring or self-configuration. Okay, so the idea is very simple. However, to do it, there are several challenges. Okay, the first challenge, because we want to optimize the performance, we want to search for the next set of configurations that can improve the performance. We need to understand how the system works, what factors the performance of our system depend on, right? So, but the system is very complex. So this is the first challenge, complex system behavior that prevents us to understand how different factors impact the performance. The second challenge is fast response to environment. So whenever there's a change in a system, we need to search for optimal performance very fast, ideally in real time, right? The third challenge is minimum footprint. So when we want to monitor and optimize the system, so we want to make sure that we don't add too much additional overhead to the system. We don't want to make the system slower because we add new things to the system. Okay, so third challenge is we need to make sure the footprint is minimal. Okay, to address the first challenge, we need to understand the relationship between the configuration parameters and the performance, software performance metrics, right? So how to do it? The first step is we ask domain experts. We ask them, so which parameters or which configuration are related to performance. So the domain expert provided us a list of parameters, right? So these parameters, some of them may actually impact the performance, some of them may not, right? So there are some opinions from domain experts, and different domain experts, they may have different opinions. So we need to verify the results, right? So we run a test that for each parameter, we specify, for each configuration, we specify the configuration parameter values, right? So we specify a combination of parameter values. We run the test, so we get a performance. For example, get a response time under this configuration, right? We run the test. And we repeat this one for so many combinations of configurations, right? So we get a number of configuration performance data points, right? So after we get these data points, so we build a regression model, like a linear regression model. This is like slightly more complex regression model. You can consider as a linear regression model, right? We build this model and we analyze that model to find which parameters or which variables actually impact performance, right? So we filter out those parameters that do not impact the performance, and we only keep those parameters that actually impact the performance. Okay, so we find only a few out of many candidate parameters actually significantly impact the system performance, right? So because we reduce a set of candidate parameters, so we can adjust the parameters quicker. Okay, this is the first challenge. The second challenge, faster response time to the environment. Okay. So we want to respond to the environment change in real time. Okay, so how it works? We know from the original system, we have the monitor data, including logs and metrics, right? So how to get the monitoring data in real time? right? So we use here we use a tool, Apache Kafka. So Kafka is a tool that can convert the data into a streaming data, right? So in this way, we can so the modern data would be streamed from the disk of the original system into any other system in a stream miner. So we would get so every millisecond we would get the results. We would get the new data from the stream. Okay. So after we get this string, modern data streams, we analyze them in a Apache Spark platform, right? So we can analyze the stream data. For example, we aggregate the stream data for every minute, right? For every minute, we aggregate the stream data. So then based on the data, we can do the optimization. We can do the adjusting, can locate the next set of optimal configurations. So here, I want to mention that you don't need to know the details of the tools. You just need to know roughly how it works. Okay. So how we do the optimal optimization? How we do a search for configurations? So here we use a hill climbing optimization algorithm. So this is a local search algorithm. Okay, you can consider it's like a climbing error race in thick fog with amnesia, right? So each step, this algorithm would move in the direction of increasing the values. Here is increasing the performance. So every time it would move, it would change one configuration parameter in the direction of increasing the performance. It terminates when it reaches a peak where no neighbor has a higher value, right? It may reach a peak that is not a global optimal peak, but it can be a suboptimal peak, right? So this is a limitation of the search algorithm, but it's fast. It's very fast. So the experiments show that this local and fast optimization algorithm can achieve the goal, can satisfy our usage scenario. Okay. So we can have a fast response to workload changes within seconds. So we can respond to the workload changes and adjust the configurations. Okay. Lastly, last challenge, minimum footprint. In order to avoid adding too much footprint to the original system, what we do is we separate all the new features. So actually we call them autonomous configuration capabilities. We separate self-monitoring, self-optimizing, and self-configuring from the original system. We put them on different machines. And the autonomous configuring capabilities would communicate with the systems remotely. So as we remember, right? We use Apache Kafka to get streaming data from the software system, original system, to our autonomous configuration capabilities, right? So logs metrics will be sent to the autonomous configuration part in a streaming miner, right? And after we get the configuration parameters, after we get the optimal configuration parameters, so we would use a remote control to set the parameters of the software system. That is how it works in this loop. Okay. So in this way, we separate autonomous configuration parameters from the original system. So the footprint is minimal. Okay. So what is the result? It's your result. So here in this figure, the horizontal axis shows the running time of our system from the start to 5 hours later. Okay. And the vertical axis shows a key performance indicator. The key performance indicator is the higher the better. 1.0 is the best, and 0 is the worst. Okay, let's see. This is when there's no such autonomous configuration capabilities. This is the old experiment. This is the original system. Okay, you can see at the start when the workload is low, right? When fewer people using the system, so the KPI is optimal is 1. But when more and more people using the system, workload is higher, the KPI drops significantly, right? And what's the result when we have this new feature, when we have this autonomous configuration? So so we can see that the KPI is always optimal, right? And when there's workload change, we can see the KPI drops a little bit, but it is pushed back to optimal value quickly, right? So this is the result of comparing with and without the autonomous configuration feature. Okay, I think that's it for the first part. Let's have a break. Let's have a short break, 5 minutes, and in next part we will discuss some sub areas of AIOps research. Okay, so I'll see you 5 minutes later. Is 1:25, right? See you at 1:25. So any questions here?